Hi, this is John Keller. This video shows how to create a molecular orbital surface in the Jvxl format using WebMO and Jmol. The video fills in some information needed for creating an interactive molecular web page, as described in my online directions. The web page, which you can see by following the lower QR code, shows a PyMO encoded in a Jvxl file. So the question is, how do you make a Jvxl file? 4 steps are required. These are listed here, and then I will show how to do this after a couple more slides. First, run a molecular orbitals calculation in WebMO. Orca or Gaussian quantum programs can be used. Export the molecule as a .mol file, and export the MO as a .cube file. In Jmol, load the .mol file, then display the MO surface. And finally, use the Jmol write command to create the Jvxl file. Actually, the web version of Jmol, Jmol, can use cube files for displaying MO surfaces. So why is Jmol necessary? Cube files are often enormous and load in the browser slowly. Jvxl files are smaller and load fast. As far as I know, Jmol is the only program that creates Jvxl files from cube files. And you can use Jmol to try different commands to optimize the appearance of the MO. The same commands are then used in the JSMol web page. What are cube files? These record the value of the MO function throughout a region, including and surrounding the molecule. The region is described by a rectangular box containing 64,000 points. To display the MO, WebMO or Jmol connects points of equal value, which is called an isosurface. The cube file for the pteropyrene PyMO is 484 KB, while the Jvxl file for that surface is only 8 KB. Robert Hansen of St. Olaf College developed the Jvxl format about 10 years ago. Okay, here is the pteropyrene molecule in WebMO. It has already been optimized at the B3LYP 631 GDP level of theory using Orca, and a molecular orbitals job has been done. Go down to the molecular orbitals panel and display the MO of interest, number 84, by clicking the magnifying glass icon. First, check out File Preferences Isosurfaces. Note that the isosurface value, which controls the fatness of the surface, is currently set at 0.03 electrons per Bohr cubed. We'll revisit fatness later in Jmol. Now go to File Export Molecule. Choose Mol format. We'll name this flat.mol since that name is used in the HTML code of the pteropyrene web page. Choose Cube format, leaving the default name. Okay, I opened Jmol in the Jmol console. First, change into the directory holding our files. Initially, use the minimum number of commands to get the desired Jvxl file. Then, we'll look into several additional commands for fine-tuning the appearance of the MO. Open the mol file. Now, using the isosurface command, display MO number 84, where MO84 is a temporary name given to the surface. Sign indicates that both the positive and negative lobes of the MO should be shown. And cutoff 0.03 specifies the isosurface value that should be used. 0.03 is the value that happened to be set in WebMO. Finally, molecule.cube is the name of the cube file. Now, JVX files contain information about only one actual surface, not the whole cube of MO values. So if a Jvxl file is written at this point, the web page will show the 0.03 electrons per Bohr cubed surface. However, I would rather show the greater extent of the MO out to the 0.01 electrons per Bohr cubed. Therefore, refresh the MO84 surface with a smaller isosurface value. Now we can write the Jvxl file. Now double check that the new Jvxl file correctly displays the MO. First delete the old surface. Then display the Jvxl surface. Notice that there's no need here to include the sign or cutoff terms because these are saved within Jvxl files. Here are some commands that could be included in the actual web page. Set the background to green using the RGB values, and make a mesh surface with no fill. To make the MO appear as it does in WebMO, reload the surface and make it translucent, and finally brighten the surface using the term fully lit. That's all.